All right, welcome to section 9. We're in the home stretch now, and this section is going to be talking about a new breed of formula called the array formula. And for those of you who have never worked with array formulas, they operate a little bit differently from non-array formulas, in that they have a slightly unusual syntax and usage that takes some getting used to. So there's a bit of a learning curve there, but once you get comfortable and learn how to use them, you'll start to see that they can open the door to do some things that you really can't do any other way. So we're going to start out this section with the rules of array formulas, how to use them, and what some of the common pros and cons of array formulas are. We'll talk about vertical, horizontal, and two-dimensional array constants, and then how to use those constants in formulas, how to use named arrays. Then we'll go into a bunch of demos in Excel. We'll start with transpose. I'll talk about linking data between sheets. I'll show you how to use the non-array versus the array approach, and compare and contrast the two. We'll talk about how to return the x largest values from a range in a single step. We'll use the len function to count characters across a range of cells. And last but not least, we'll create a custom max if function. So as usual, 2 files to download: Excel for Analysts Array Formulas, the PDF, and the Section 9 Array Formulas Excel file. So go ahead and open those up, and let's hit it. Okay, so what the heck are array functions? Basically, they're designed to perform multiple calculations on one or more items in an array. What makes them very different from normal cell functions is that array functions can either take the form of a single cell formula, in which case they exist within one cell, or a multi-cell formula, in which case it's the same formula applied across a number of cells. Very important note is that you must press Control-Shift-Enter to enter, edit, or delete any array formula. If you don't press Control-Shift-Enter, if you just press Enter like you're used to, these will not work. So worth repeating again, press Control-Shift-Enter every time you enter, edit, or delete an array formula. And when you do that, you'll see that Excel will automatically add brackets around your formula, starting before the equal sign and going all the way to the end of your formula, which indicates that the function applies to an array. So let's take a look at one example. If I were to select the range from D2 through D5 here and type the formula B2 through B5 times C2 through C5 and hit enter, the formula will only be applied to cell D2. If I select that same range, type the exact same formula, and hit Control-Shift-Enter, I've then created an array formula, and it applies to all cells in the range that I'd highlighted. So as you can see, the results populate across all 4 rows within my array. So rules of array functions, unfortunately, there are quite a few, and you must obey all of them in order to use these properly. The first, like I've mentioned multiple times now, is that you must press Control-Shift-Enter, sometimes abbreviated as CSE. Some people call array functions CSE functions for that very reason, to edit or enter an array formula. Rule 2, for multi-cell array functions, you must select the range of cells before you enter the formula. So step 1 is understanding what range of cells you want your formula to be applied to, and then step 2 is actually writing the formula. Rule number 3, this is an important one. You cannot change the contents of any individual cell, which is part of an array formula. It's kind of strict in that as soon as you write an array formula that's specific to an array, you can't insert rows, you can't delete values, you can't move cells if they're part of that array. Rule 4, you can move or delete an entire array formula, but not a piece of it. So oftentimes, if your array needs to change, you have to delete your entire array formula and rebuild from scratch. And then last but not least, number 5, you cannot insert blank cells into or delete cells from a multi-cell array formula. So bottom line, press Control-Shift-Enter, select the range of cells before you enter the formula, and make sure that your array is not going to change once you've written the formula. So those are the rules of array functions in a nutshell. All right, so you may already be getting the sense that array functions, although they can certainly be incredibly powerful, can also be a total buzzkill to work with, especially as you're first getting familiar with them. They do tend to be a bit more rigid and strict than non-array functions, so the learning curve is a bit steeper here. Regardless, let's take a look at some of the common pros and cons. On the pro side, first, they're really great tools to condense multiple calculations into one formula, which has the added benefit of often reducing file sizes. Second, they can perform some complex functions that non-array formulas cannot. And I'm going to walk you through some examples that demonstrate that. And then third, they help to reduce the risk of human error, such as accidentally deleting parts of arrays or mistyping formulas. On the con side, it can be very difficult to modify or delete existing array formulas. It can be kind of clunky to work with. You have limited visibility into the formula's function, especially for users who are not familiar with arrays. So it just makes it a little bit trickier to QA, to troubleshoot, and to identify how combinations of functions may be working. Third, it eliminates the option to modify cells contained within arrays. So if you have a data set that tends to change quite a bit, array functions may be very difficult to work with. And last but not least, they may actually reduce processing speed if multiple array functions are used. So personally, in the work that I do, I find myself working with very dynamic data that's constantly changing and updating, in which case there are many cases that array functions aren't the right fit for me. But that said, there are certainly opportunities where I've used array functions because there's no other option that could have accomplished the same thing. So at the end of the day, it's really just a function of what data you're working with and what you're trying to accomplish when it comes to using array functions versus non-array functions. So with that, let's talk about the different array types and named arrays, and then we'll jump right into Excel. Okay, so array constants are arrays that are created by manually entering a list of items directly into the formula bar and surrounding that list with brackets. So there are three types. There's horizontal array constants, which create an array contained within a single row. Those are delimited by commas. So what you do is select the horizontal array of cells that you want to create, in this case A1 through D1. If we wanted that array to populate with the numbers 1, 2, 3, and 4, we would type equals open bracket 1, 2, 3, 4, close the bracket, and then hit Control-Shift-Enter. It's important to note that you have to manually type this set of brackets, and when you press Control-Shift-Enter, Excel will then add a second pair of brackets around the whole thing. So that's the horizontal array constant. Vertical array constants work the same way. You just select your vertical array of cells, and then you delimit your values by semicolons instead of commas. So if we were to populate an array from A1 through A4 with the values 1, 2, 3, and 4, we would type equals open bracket 1, semicolon, 2, semicolon, 3, semicolon, 4, close the bracket, then hit Control-Shift-Enter. And last but not least, you can combine horizontal and vertical array constants to create two-dimensional array constants. So to write a two-dimensional array constant, or to create one from scratch, you basically input your values the same way that you would read a book, starting in the top left, each row moving from left to right. So you list the sequential values from columns A to B to C to D, separated by commas, and then use a semicolon to indicate a jump down to the next row. So in this case, we have the values from 1 through 8, and since 1, 2, 3, and 4 all fall in the same row, those are separated with commas, and then the semicolon indicates that the 5 is starting on the second row, back in column A. So again, press Control-Shift-Enter, and your array will populate. So let's bounce over to Excel. I'm just going to open up a blank worksheet just to get some practice working with this. So let's select A1 through D1, go into the formula bar, and we'll type equals open bracket 1, 2, 3, 4, close the bracket, and if I just press enter now, you'll see that value populates in cell A1, the number 1, but B1, C1, and D1 remain unaffected. The issue is that I didn't press Control-Shift-Enter. And when I do that, now you can see that it's added the second pair of brackets around my function, and it's populated the array that I had selected with the values that I had input here. So that's how to create a basic horizontal array. Let's take a look at how to edit and delete that array. So the challenge is, now that I have my array function written, if I want to change the 4 to a 5, I can't just change the cell value because it's part of this array. So press cancel. Similarly, I can't just go into the formula bar and change it there for the same reason. So what I need to do is basically select the entire array, go into the formula, change the 4 to a 5, and then press Control-Shift-Enter again to update the array. When it comes to deleting the array, similar case, I can't just delete individual cells. What I have to do is either select the entire array and delete the values that way, in which case the functions disappeared, or I'm going to undo that. I can select the array, go into the formula bar, delete the formula, and now here's the catch. Even though there's no formula written there, if I press enter, nothing happens. So I can keep hitting enter over and over and over, and nothing's going to happen. I have to press Control-Shift-Enter, even when I've deleted the function, to fully clear the array that I just created. So again, learning curve is a little bit steep. Once you start playing with this, it starts to become a bit more natural. But again, definitely much more strict and rigid than traditional cell formulas. So let's create a vertical array. I'm going to select A1 through A4, go into the formula bar, type equals, open bracket, 1, semicolon, 2, semicolon, 3, semicolon, 4. So remember, the semicolons are what indicate or delimit different values that fall in individual rows. So close the bracket, Control-Shift-Enter, and there you go. It's populated my array in cells A1 through A4. So again, to delete that, I'm going to delete the function, press Control-Shift-Enter, and it's gone. So let's do one more example. We'll do a two-dimensional array from A1 through B4. So in this case, I'm going to type equal bracket, and then remember, it's just like you're reading a book. So it's going to start with whatever value I want in A1, followed by B1, then A2, B2, A3, B3, A4, B4. So why don't we just do sequential numbers again? So 1, and then comma takes me to the next column value, which is 2. Semicolon jumps down to the next row, 3, comma 4, semicolon 5, comma 6. You can close the bracket, Control-Shift-Enter, and whoops, I needed one more pair of numbers for this to fill the full array that I'd selected. So this is a good example. Why don't we just go back into the function, add one more semicolon, 7, comma 8, Control-Shift-Enter, and there you go. That's the proper array. So horizontal, vertical, and two-dimensional arrays. So 2 important things to note about array constants. The first is that they don't just have to contain values, as I've been showing you. They can also contain text surrounded by quotation marks, or even logical values or error values. And second, rather than being used just to populate cells, they're more often used as part of array formulas. So looking at this example here, as you can tell, there's an array constant nested into a larger array formula. And there are actually 4 things going on here. We've got our sum function, a stored array, which is just the reference to A1 through A5, the multiplication operator, and finally our array constant surrounded in brackets. And because these numbers or values are delimited by semicolons, I know this is a vertical array constant. So all that this function is doing is it's taking each value in the array from A1 through A5 and multiplying it against its corresponding value in the array constant that we've nested in here. So basically, the sum function is just adding up or aggregating all of those products. So 5 times 1, 8 times 2, 2 times 3, 7 times 4, and 3 times 5 to arrive at a total of 70. So tip here, like I mentioned, These brackets surrounding the array constant are manually added. The outer brackets are added once you press Control-Shift-Enter to convert this into an array function. All right, so let's hop over to Excel and get a little practice with this. First things first, I'm going to create a vertical array constant. So I'm going to type equals bracket 1, 2, 3, 4, 5. Close the bracket, Control-Shift-Enter. And now I'm going to select B1 through B5. And I'm going to create a multiplication problem. That's just going to be the values in A1 through A5. That's my stored array. Times, and now I'm going to nest a new vertical array within this formula. Rather than creating one separately and then referring to the cells that it's populated, I'm just going to work it right into the formula. So I'm going to do 10, semicolon, 20, 30, 40, 50. Keep in mind that if I were to put commas here, it would screw everything up because it would be trying to multiply values moving down row by row by values moving over column by column, and things wouldn't align the way I want them to. So right now I'm creating an array with the same dimensions as A1 through A5 so that I get a clean kind of one-to-one relationship. So I'm going to close the bracket, Control-Shift-Enter to finish that. And as you can see, this seems to be working properly. Basically what it's doing is saying A1 times 10, which is 10, A2 times 20, 2 times 20 is 40, 3 times 30 is 90, 4 times 40 is 160, and finally 5 times 50 is 250. So as you can see, I've saved a step by just inserting this constant into the array function. So in the next section, we're going to talk about how to actually name these arrays so that I don't have to write 10, 20, 30, 40, 50 from scratch. If I'm going to be using it over and over, I can give it a name and then just type the name into the formula, the same way that we use named arrays in some of the earlier sections. All right, so just like normal cell ranges, you can assign a name to a certain array constant. The only difference is that in the refers to box, you write it just like you would if you were trying to populate cells. So you'd add the brackets and either delimit by semicolons if it's a vertical array, commas if it's a horizontal array, or a combination of both if it's a two-dimensional array. So all you need to do is just go into formulas, either name manager or define name, create a name for your array constant, and then type it just like you normally would in a refers to box. And note that you don't have to press Control-Shift-Enter here. You just type it in with the brackets and press OK. That will store the array constant with a name so that you can either populate cells by just typing the named array, or you can replace the array constants with the named array if it lives within a formula. So even when you're just typing the name for an array constant, you still have to press Control-Shift-Enter for it to populate. So let's jump into Excel and do a little practice with this. Again, just working with the blank workbook for now. But why don't we start by creating, a standard vertical array from 1 through 5 equals bracket 1, 2, 3, 4, 5. This should be very familiar by now. Control-Shift-Enter. So that's one way to add the array. And as you can see, it's stored as an array constant with each of the 5 values. Now what I could do is go into formulas, define name. I'm going to give it a name called numbers. And then here where it says refers to, I'm going to delete everything after the equal sign, type the bracket, and then the exact same thing. 1, semicolon, 2, 3, 4, 5. Close the bracket off, press OK. And now if I select B1 through B5, and in the formula bar, type equals numbers, you can see Excel has flagged it because it knows that there's a named array called numbers. And I can press Control-Shift-Enter, and it will apply that array to my selected range. So let's do the same thing, except instead of using numbers, let's create a named array with text. So I'm going to call this one text, and it's going to refer to another vertical array that's going to be, in quotes, 1, semicolon, 2, semicolon, 3, semicolon. Sorry, blocking you there. 4, semicolon, 5. So just make sure that you're surrounding each of your values in quotes, that you're surrounding the whole thing with brackets. So I'll press OK. It saved that named array as text. Now in C1 through C5, we'll just type equals text. You can see it's recognized it. Control-Shift-Enter, and it will apply the text array there. So now just to use those stored or named arrays as part of a function, it really works the same way. So let's say we just have 5 random numbers in a vertical array from A7 through A11. What I can do in B7 through B11, if I want to do a similar multiplication problem that we did in the last lecture, but use or refer to a named array rather than an embedded manual array, I could do that. So I'll type equals A7 through A11 times, and then here's where we would have done, 1, semicolon, 2, 3, 4, 5. So this is kind of how we used to do it. Now let's edit that. Instead of putting the manual array in there, let's just write numbers. So A7 through A11 times the numbers array. Control-Shift-Enter, and we'll get the same response. So those are just a few examples of how to use named arrays with array constants to make your life a little easier. Next up, we're about to dive into Excel and walk through a bunch of different demos. All right, so the first array formula demo that we're going to do is called transpose. And basically the transpose function just allows you to change the orientation of a given data array. So for instance, if you have an array that's 5 rows tall by 2 columns wide, transposing that would change it into an array from 2 rows tall to 5 columns wide. One thing to note that makes this a little bit tricky is that the range in which you enter a transpose function must be the exact dimensions of the transposed data. So syntax-wise, couldn't be simpler. It's just transpose and then the reference to your original array. And again, since this is going to be an array function, Control-Shift-Enter to lock it in. One little tip here, there are multiple ways to transpose data. And if you want to transpose a data set that you will want to later edit, you can transpose it as just values as opposed to a formula using paste special transpose, which is the Alt-HVT shortcut that I showed you back in the first section. So let's jump to Excel. This time we're going to open up our Section 9 Excel workbook, Array Formulas. And it's a pretty simple workbook. We've just got one tab to work with called Sales Data. As you can see, I've got a year column here, a list of store locations, including Boston, New York, and Detroit, and then some hypothetical numbers for revenue, spend, profit, and ROI. And we're just going to work with this data array as we practice some array functions. So I'm going to show you 2 ways to transpose this data. The first way, which is the simpler route, if you just need the values to be transposed, and that's that, it's just to grab the array from A1 through F10, hit Control-C to copy, select any cell where you want to drop your transposed data, and then hit Alt-HVT. That's Paste Special Transpose. And as you can see, it's changed from a 6 by 10 array into a 10 by 6 array. And it's basically just moved the values into a new orientation here. The second way is to use an array function. So remember, I need to select the perfect dimensions of my transposed data before I write this function. And I'm actually going to show you the wrong way to do it first so that you get a sense of what happens if you don't follow those rules. So I'm going to just pick a random array like this. And in the formula bar, I'm going to type equals transpose. And then again, my array is the original data set. Close the parenthesis. And now I'm ready to just press Control-Shift-Enter to transpose it. So what the transpose function will do is it will fill up the array that I've selected, and any cell where it can't find the appropriate value from the original array, it will just fill in with an NA. So I'm going to delete that, Control-Shift-Enter to get rid of it. And now I know I want a 10 by 6. So there's 10 columns wide. 2, 3, 4, 5, 6. And let's start over and type transpose one more time. Again, the array is A1 through F10. Close it, Control Shift Enter. And there you go. If I want to give this the same formatting, that's kind of what's nice about Alt HVT, is that it preserved the formatting. So I can just grab this chunk in the Home tab, press Format Painter, click the top corner here, and it will apply the same formatting. So as you can see, right now the same transpose function will appear anywhere I click within this array. So there you go. 2 different ways to transpose data. And again, it depends on what you're trying to do here to determine which approach to take. If you need to maintain a link to your original non-transposed array, then the array function is probably the best bet. If you're looking just to reorganize your data and then edit or modify that data later, then the Alt HVT shortcut is probably your best bet. Either way, that's transpose function. All right, demo number 2 is about linking data between sheets. So let's return to our sales data tab. I'm actually just going to delete the columns that we had created from the transpose exercise. Now what I want to do is just duplicate the values in A1 through F10 by just linking them to a new sheet. So I'm going to show you 2 approaches, the non-array approach first, followed by the array approach. So I'm going to create a new tab. I'm going to call this duplicate 1. And all I'm going to do is write a cell formula in cell A1, just equal to sales data A1. Press enter. And since this is a relative reference, I can just drag it out to F, down to row 10, and it will duplicate the array in the sales data tab. And as you can see, each cell has a different function because it's linking to a different cell in the sales data tab. And again, if I want to be particular about my formatting, I can also use the Format Painter to apply formatting between cells. So now I've got duplicate data on 2 tabs. Let's create a 3rd tab called duplicate 2. And in this case, I'm going to select the entire array that it will fill and then press equals sales data A1 through F10. Only difference is I'm going to hit Control Shift Enter as an array function. And there you go. It's pulled in all of the correct data from the sales data tab. Again, I'll just copy the formatting and paste it there. And so there you go. 3 versions of the same data set. The difference now when you look at these cells is that in the duplicate 1 version, I have a total of 60 formulas here. Granted, they're simple formulas, but each cell has a different formula. In the array version on duplicate 2, anywhere you click, you'll see that it's just one function because it's being applied to an entire array in a single step. So that's just a demonstration of how array functions can help you consolidate formulas in a case like this. And so, even if I were to change values here, so 2015 Boston spend was actually 1,000, that will actually update properly in both the array and the non-array versions. So there you go, linking data between sheets using array functions. All right, so now that you have a sense of how these array formulas work, let's start integrating some of the tools and functions that we've learned in previous lectures and see how those can be used as part of array functions. So the first example that I want to show you is, let's say I want to pull out the top 3 years of revenue from column C. So in H1, I'm just going to write top 3. And the first way that I would think to do it, the non-array version that we've already learned, would be to use the large function. So equals large, array is C2 through C10. Press F4 to fix that. And then for the number 1 largest, I just type a 1 for the K value, close it out and hit enter. I could just copy that, paste it 2 more times, and just change the K value to a 2 for the 2nd largest and to a 3 for the 3rd largest. So that's the non-array version. If I want to format these the same way, I can use the Format Painter. So that's 3 separate formulas to return the 3 largest values from column C. Let's do the same thing here. So top 3. This time I'm going to use an array function to do the same thing. So remember, I'll start by making my selection of all 3 cells, I2 through I4. And then the formula bar, I'm going to type equals large. The array that I'm looking for the largest values is still C2 through C10. The only difference here is that for the K value, because I'm looking for all 3 largest values, I can't just put a 1 or a 2 or a 3. I need to put an array constant in here. So I'm going to open the bracket and do a vertical array constant from 1 through 3, since I'm looking for the 3 largest values, and the array that I've selected is a vertical array 3 rows tall. So then I just need to close that parenthesis, Control Shift Enter, and there you go. So same formatting, as you can see, getting the exact same top 3 values. The only difference is that I have 3 formulas here in column H, just a single array formula in column I. Now what if I wanted to change this from the top 3 to the top 5? Again, I could just copy this, paste it down 2 more times, change the 3 to a 4 and the 4 to a 5. For the array version, what I could do is select a vertical array with 5 rows in it. And I could add a semicolon 4, semicolon 5, and Control Shift Enter. And there you go. Again, just update the formatting here. Change this to a top 5. And again, 2 ways to accomplish the same thing. All right, so the next demo that I want to share with you is about counting characters across a range of cells. And this isn't a particularly difficult one. It's actually quite a simple array function, but it's a good example of a task that you can't accomplish in a single step unless you use the array formula. So if our goal, for whatever reason, is to count the number of characters across this entire range of store locations, B2 through B10, if I were to take the non-array approach, what I have to do is type a series of len functions that relate to column B and just apply it down. So that gives me the number of characters in each of these city names, including spaces. And then I would have to write a sum function down here to give me the total. So 63 characters across this entire range. I can also do the same thing with an array function in a single step. And I could start with the length function and apply it to B2 through B10. But the problem is, even if I enter it with the Control Shift Enter, I only get 6 because it's only calculating the length of the first cell in the reference. So what I need to do is just insert a sum function in here as well. So it's going to be the sum of the lengths of each of the strings in every row of my array. And now, once I hit Control Shift Enter, as you can see, I get the same total in one single step as opposed to about a dozen. So one example of how you might be able to work more efficiently by taking the array approach versus the traditional cell formula approach. All right, so for the final demo, I'm going to show you how to build a custom maxIf function. And this is a great example of where array functions can come into play when your non-array or traditional cell formulas may fall short. So if you recall, in the statistical function section, we talked about SUMIFs, COUNTIFs, AVERAGEIFs. Unfortunately, there's no equivalent formula if you want to calculate the max value in a column based on some criteria. So there's no maxIf out-of-the-box function that we can use. Luckily, array functions can do the job. So what I want to do here is return the max value for revenue in column C based on a specific store location name. So one of these 3 city names. So the first thing I want to do, just for the sake of showing you an example, is just name this array city. And I'm not making a array constant. All I'm doing is just naming the range from B2 through B10, just so that we remember that that is an option to help save some time when we're writing this function. So that array is now called city. What I'm going to do is write one of the city names right here in H8. I'm going to type Boston. And then in H9, this is where I'm going to type my max if function. So it's going to be a relatively simple function. We're going to start with equals max, open the parenthesis, if, and now the logical test is going to be city. You see it's kind of triggered the array because it recognized it as a named array. And city equals whatever values in H8. Right now it's Boston. And if I change that value, it would pull in the max for New York or Detroit, for example. And then the value of true is just going to be the array from C2 through C10, which is my revenue field. That's where I'm trying to extract the max value from. So I'll close off two parentheses, and then Control Shift Enter, and there you go. So grab the formatting from up here in the Home tab. Boston, $1,726. We can do a quick spot check and confirm that that is the max value for Boston. And now if I change this to New York, for instance, you get 1944, which is also correct. And Detroit, 1743. There you go. So great way to kind of create our own custom function where we didn't have the option using our traditional statistical formulas. That wraps up the array formula section. This is really just a small sample of the types of analyses that you can do with arrays. So I encourage you, once you get comfortable, just start exploring how and where you can use these in other areas. So next up, we got one final section covering some bonus functions. We're going to do some really, really interesting demos there. So stay tuned for the final stretch. All right, so I actually lied. I've got some additional array function demos that I want to share with you guys that I've come up with since the course was originally published that really help to demonstrate just how versatile and powerful array functions can be. So in this lecture, I want to actually pick up on the maxif function that we just completed and make it a little bit more complicated. So instead of just basing the maxif on one criteria, where city equals Detroit or Boston or New York, I want to update that maxif array function to account for multiple criteria, specifically both location or city and the year. So jumping back into the workbook, the first thing I'll do is just select A2 through A10 and name that range year, just to make it a bit easier to work with. And now here in I8, let's just put 1 year. Could be anything. I'll put 2014 here. And now in cell I9, this is where I want to enter my new maxif function. I'll actually just drag this over to give me a good starting point. I can edit the references. City still needs to equal H8, and the values we're searching for the max within, it's not D2 through D10, it's still C2 through C10, the revenue field. So if I press Control Shift Enter, you'll see that I've got the same starting point as before, and now I can just add that second criteria in here. So what I want to do is actually surround my first criteria, city equals H8, in parentheses. I'm going to multiply that by my second criteria, which is year. You can see it identifies the named range equals I8. I'll close that parenthesis. So I've got two criteria, each surrounded by parentheses, separated by a multiplier. I'll show you why in just a minute. So if I Control Shift Enter, now it returns 1609, which is the max value if city equals Detroit and year equals 2014. So Detroit, 2014, 1609. Now, obviously, it's the only value that exists for Detroit 2014, but to give that a test, we can change the 2013 to 2014. And now, as you can see, the max value changes from 1609 to 1743. So I'll just undo that change. It's back to 1609. Now let's dig in a bit, try to understand exactly how this is operating. And the best way to do that is to use the Evaluate Formula tool. So with this cell selected, I can go into Formulas, Evaluate Formula, and this will walk me through each step of the function and how it's evaluated. So we're going to start with the city underlined. And when we evaluate the city named range, it translates it into the array of 9 different rows of data. Boston, 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 New York, New York, New York, Detroit, Detroit, Detroit. So we're now looking for cases where the values within that array equal the value in H8, which evaluates to Detroit. And as Excel cycles through this, it's going to translate that statement into an array of trues and falses. So for every row where that condition is true, where the city equals Detroit, it will return a true. And for every row where that criteria is not true, it will return a false. So that first criteria, city equals H8, translates into false, 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 true, 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 since only the last 3 rows within this array meet that criteria. Next up, we're going to do the same thing with our year criteria. So year evaluates to an array containing all of our dates in these 9 rows in column A. And we're searching for cases where the values in that array are equal to the value in I8, which right now is 2014. So this will evaluate in a very similar way. It will translate this statement into another series of trues and falses. In this case, we have false, true, false, false, true, false, false, true, false. And as you can see, that makes sense because for every 3 years, only one is 2014. So now here's the key that allows this function to return the proper value. We've created 2 arrays based on our 2 criteria. The first array contains true and false values based on rows that match the location city. The second array contains true and false values based on rows that meet the year. So when we multiply these 2 together, the result is a single array of zeros and ones, which can be interpreted exactly the same way that you'd interpret trues and falses, where true is equal to 1, false is equal to 0. So what we have here now is an array that looks like 0, 0, 0, 0, 0, 0, 0, 1, 0. So only one value in that array populated as true. And that's because any instance where one criteria or the other failed to be met, when those 2 values are multiplied, one of which has to be 0, it will result in a 0 in the final array. So a 1 indicates the row within our array where all criteria have been met. And in this case, it's the second to last row. And if you just look at our data here, that second to last row, row 9, is the row that contains both the year we care about, 2014, and the city that we care about, Detroit. Now, the last bit of this function, the if statement, essentially just assigns a value from within the range from C2 through C10 to any value in our array that's not equal to 0. So in other words, we're going to pull out the value from the second to last cell in the range from C2 through C10, since the second to last spot in our array is the only non-zero value. And as you can see, it results 1609, since that's the second to last value in our array from C2 through C10. And now we're just left with a simple max function. So what's the max of false or 0? 0, 0, 0, 0, 0, 1609, 0? It's 1609. And that's the value that gets returned. So as you can see, array functions are very, very different from normal cell functions in that they kind of cycle through these processes all within the same formula, within the same cell. And that's what makes them so powerful. Okay, let's walk through one more example just to show you how array formulas can sometimes be used to do things that cell formulas simply can't accomplish. So in this case, sticking with our example data, let's say someone asks you, how many years did profit exceed spend in this data set? If you were to accomplish that using cell formulas, you might do something like a conditional statement that says if E is greater than D, then return a 1, otherwise 0. And you could apply that down and then take the sum of that column. And there you can see, okay, there were 4 years or 4 rows in this data set in which profit exceeded spend. But that took 2 steps. I used 10 formulas total. Array functions can do this with a lot more elegance and with a lot less processing power. To do that, let's just say, profit is greater than spend. Go into home menu and align that, make it italic. And here's where I want to return that same value of 4. So I'm going to actually use an array function using sum. So I'm going to say equals sum. And now instead of just a single number or a single traditional range of numbers here, I can actually input 2 ranges of data here all at once. So I can say E2 through E10 is greater than D2 through D10 and close the parenthesis. So in theory, what this should do as an array function is cycle through each row within both arrays and tally up a true or a 1 in any case where the criteria is true, or where column E is greater than column D, and a 0 otherwise, and then take the sum and return a 4. So if we Control Shift Enter, you'll see we get a 0, which is obviously not what we want. So let's go into formulas, evaluate formula, and see what's going on here. So when this greater than statement is evaluated, it does result in the array that we'd expect: false, false, true, true, false, true, true, false, false. And as you can see, there are 4 true values in positions 3, 4, 6, and 7. And if you look at those specific rows within our data, row 1, 2, 3, 968 is greater than 758. 4, 980 is greater than 964. 6, and 7. So those are the correct positions or the correct instances of rows that match that greater than criteria. Problem is when we try to sum this statement, it evaluates to 0. And the reason is that even though in many cases Excel will treat falses as 0s and trues as 1, with a sum statement, it doesn't know how to handle those values. So Excel actually has a very useful little tool called the double unary, and that essentially converts non-numeric Boolean values, true and false, into actual 1s and 0s. So if we dive back into our function here, right after that first parenthesis, I'm going to do 2 dashes. That's the double unary. Now I need to open the parenthesis again and close out the second at the very end. Now if I Control Shift Enter, it returns the proper value of 4. So anytime you have an array function where you need to convert a specific array from Boolean values into 1s and 0s, that double unary should do the trick. All right, time to pat yourself on the back. You just finished the array section. Crazy, crazy stuff. Definitely a little bit tricky to get used to and very, very different from the traditional cell functions that we've been talking about. Now, again, like I said before, this is really just scratching the surface and giving you a few select examples of how array formulas can be used in Excel. That said, once you master the fundamentals of how array formulas work, you can pretty quickly start applying them in more complicated or more advanced ways. So, homework time for anyone interested in digging in a little deeper and getting some more practice with these. In the homework exercise file that's available in the course resources, we've got 2 tabs with array exercises. The first one is array functions, and here we're going to practice some stuff like max if with multiple criteria, using that double unary to convert Boolean values into numbers. And then last but not least, we've got this bonus array function tab, which is where things start to get really hairy. Essentially, what we're going to try to do here is use an array formula to return a subset of this range from A3 through D14 based on specific criteria. So we want to return that subset right here in I3 through L14, but only for rows that meet the start date, end date, and minimum revenue criteria assigned here in column G. So I'm actually going to give you a little sneak peek at the answer file, because what I've done is laid out a step-by-step explanation in my own words of how this thing's actually operating. And if you take a little peek at the function, you can see that it's kind of a beast. That said, this is probably not the only way to do this. Keep in mind that this is the approach that I chose to accomplish this, but there may very well be others. So as always, post to the discussion board if you need help, message me directly, or if you just want to say hi. Always here to help. Thanks, guys. Good luck. All right, welcome to section 10, Congrats on making it this far. We're nearing the end of our journey together, and trust me, we are going to finish strong. This is the bonus badass function section, which is basically just my excuse to pull together a handful of what I feel are some of the most underutilized yet most powerful and versatile functions that Excel has to offer. So this section is going to be really hands-on. We're going to focus on demos and project showcases. We'll start with the indirect function, then jump into Excel, and we'll show you how to dynamically change a lookup array based on a cell's value, which can be a really, really useful trick in certain contexts. Next up, I'll show you hyperlink, which is basically how you allow people to bounce around between locations within your worksheets and workbooks. The demo for this case will be jumping to a sheet name that's stored in a cell. And last but not least, we've got web service and filter XML, which are just two unbelievably powerful functions that let you tap straight into real-time data sources from places like URLs and API sources. You don't need coding experience for this. There are a ton of different examples of how you can use this in a number of really cool ways. I'm going to show you how to pull in real-time weather conditions through an API, and also give you a little sneak peek at a tool that I've built to also integrate Google navigation data. And then we've got two files to download, the Excel for Analysts Bonus Functions PDF and the Section 10 Bonus Functions Excel file. So get excited because this one's going to be fun. All right, so I want to kick things off with a function called indirect. It's a really cool, really powerful function, but I got to be honest, it's a little bit hard to wrap your head around at first, and it's even harder to explain in words. So bear with me. I'm going to walk through a number of examples that should hopefully explain how and why it can actually be a really useful function. So what it does is it returns the reference specified by a text string in a cell. And then you can use that reference as part of formulas and modify those references without actually changing the formula itself. So the syntax is really simple. There's only one required component, which is the reference text. That's just a link to the cell that includes the text that you're evaluating. So it's a basic cell link. The second piece, which is optional, essentially tells Excel how your reference is formatted. The references that we've been using with columns as letters and rows as ones is the default, and that's what we're accustomed to. Just a heads up, there's also an alternate version in the R1, C1 format, and essentially that just stands for row 1, column 1. So for instance, B1 in the format that we're used to equates to R1, C2, or the cell in the first row, but second column, which in our world is column B. So let's look at 3 examples here. In the first case, we're using a row function, and we're saying, all right, tell me what the row of cell B3 is. When you do that, Excel just says, okay, cell B3 is in the 3rd row, so that's a 3. And that's just like we learned the row function in the past. Now when you insert an indirect function here, as you can see, cell B3 actually contains a text string, B1, that could be interpreted as a cell reference. So if we say row indirect B3, now Excel is going to go to B3, but before it says, well, B3 is in row 3, it's going to say, well, what is the text that B3 contains? And it says, oh, B3 contains the text B1. So the indirect function is telling me you actually want the row number of B1, which is 1. So indirect allows Excel to see that cell B3 contains a reference and then returns the row of the reference, not the cell itself. So the third example here is doing the exact same thing, just using the R1, C1 format. So rather than B1, it's referring to R1, C2. In both cases, it returns row 1. So let's be real. The indirect function is pretty confusing at first. It took me a little while to get a handle on exactly what was going on. But here are a few more examples that can help you out. So let's take a look at this little array of data here. In the first case, we're just saying, what's the sum of cell D2? And we get a 0 because Excel is saying, all right, well, D2 just contains a bunch of text in it, B3 colon B5. None of that's a value, so it doesn't really equate to a sum, so it's going to return a 0. But if you say sum of indirect D2, Now indirect is telling Excel to recognize that the cell we're referring to, D2, contains a reference, not a value. So it takes that one additional step and says, okay, you're showing me a reference, which is B3 through B5. So I'm going to evaluate the sum of that, which is 16, because B3 through B5 is 5 plus 8 plus 3. And you can also use these in VLOOKUP functions, which is a really important usage for the indirect function. You could say, let's VLOOKUP the letter A in the lookup array of D4, and then return the value in the second column over. When you do that without an indirect function, you're basically trying to find the value A in a single cell lookup array, which doesn't make any sense. So it's going to give us an NA error. When you integrate the indirect function immediately before that D4 reference, now we're saying VLOOKUP A within the reference contained within D4, which is A3 through B5 over here. And now when you do that, it finds A in the third row, jumps to the second column, and returns a 5. So it's basically just telling Excel to go one additional step and evaluate the actual text within a cell. And if that text reflects a reference, to use that reference as part of the function that it's trying to complete. So let's jump to Excel and get our hands dirty. Open up the Section 10 Bonus Functions file. You'll see a number of tabs here. We've got sales data on the first tab. That's where we're going to live for this example. We've got a blank tab called Pick a Door. That's going to be for the hyperlink function. We've got the Weather API tab, which is going to be the third demo we're going to talk about. And then some secret Door 1, Door 2, and Door 3 tabs, which we'll get into the next lecture. Try not to peek in the meantime. So here we are with sales data. We've got 3 little kind of arrays of data here with some revenue, spend, profit, ROI numbers for different store locations for a given year. So we've got one observation from each store for 2013, 14, and 15. And I've built out just a little placeholder here. And what I want to do is create a dynamic VLOOKUP function that pulls in these metrics, the revenue, spend, profit, and ROI for a given city based on the year that's selected in cell J2. So if the user has selected 2013, I want the lookup to reference this array here. If the user selected 2014, I want them to use this array, and so on and so forth. So if I just started writing, a VLOOKUP function, you'll get to the point where you need your lookup array, and you can't just select one. You could also do this with a series of if statements. You could say, if J2 equals 2013, VLOOKUP blah, 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 blah. If J2 equals 2014, VLOOKUP blah, 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 and so on and so forth. And that's totally fine. It's valid. It's a perfectly fair approach. I just want to show you an alternate version which can do it in a bit more of an efficient way using the indirect function. So what I'm going to do is create a value in K2, which is going to return the reference that I want my VLOOKUP to include for the lookup array. So what I'm going to do is create a value in cell K2, which is going to return the text string that I want to input into my VLOOKUP formula, depending on the year. So this is where the cell references will live as text. You're going to start with equals if J2 equals 2013. My value of true is going to be the text string that will give me the correct lookup reference for my VLOOKUP formula when the year is 2013, which is going to be B2 through F4. So remember, this is a text string here, so I'm just going to type in quotes B2 colon F4. If I don't put quotes, it's going to read that as an actual reference and get confused. For value of false, I'm going to just copy this chunk and paste it again. And now just say, okay, if it's 2014, now my reference is going to be B7 through F9. So I'll just edit the rows there. And then I'll comma and paste that chunk again. So where it's 2015, I want it to equal B12 through B14. And then close 3 parentheses off, press enter. And now you can just see that each time I change this filter, the text is changing here. And that text, again, is going to drive the lookup value in my VLOOKUP function. So here's where I'm going to actually write the lookup functions. First one I need is Boston revenue for the given year. So I'm going to type equals VLOOKUP, and the lookup value is going to be a city name, Boston. Table array. So this is where normally you would just say, here's my array, B2 through F4. In this case, I'm going to delete that and write indirect K2. And I fix that because that's always where the indirect function needs to read. So indirect K2, column index number for revenue is going to be in the second column over because it's column C. And I want to exact match it, so I'll drop a 0 there and close the function. So now when I hit enter, Boston revenue for 2013 is $10.99. Looks good. What I can do now is, what I'll do is fix the column reference in the H5. So press F4 3 times. That way I can drag this over and just change the column index from a 2 to a 3 to return spend, a 3 to a 4 to return profit, and a 4 to a 5 to return ROI. And what I'll do is and I can just format this as a percentage. There we go. And now all of my references should be in a good place so that I can just drag this down and it will apply because it's pulling in the new city name in each new row. So New York and Detroit. Let's check these values. 2013, New York, 1944, Detroit, 1743. Looks good. And then let's try the ultimate test, which is actually changing the dropdown. As you can see, things look good. Our reference text is changing in K2, and as a result, it's feeding into the VLOOKUP formulas, which are returning different values each time. So everything looks good. Last thing I might do is just hide that with white text so that it looks like a nice, clean tool. And there you go. That's how you use the indirect function. All right, so it's time to talk about arguably the coolest sounding function in Excel, which is hyperlink. Turns out it's actually a pretty awesome function too. It creates a shortcut that links users to a document or location within a document. And that doesn't just have to be within a worksheet or workbook. It could also be a document that exists on a network server or via web address and so on and so forth. So syntax-wise, really, really simple function. You just input your link location, which is where people will go if they click. And then you have the option to add a friendly name, which is how you want the link to read. So by default, the link will read exactly as the location, but you can give it a label if you wanted to, if you want to customize it a bit. So 3 examples here. In one case, you can hyperlink to a web address or URL that drives to a certain document. You can hyperlink to a location on your machine. And then last but not least, you can link to specific sheets or locations, even specific cells within your workbooks. So a pro tip here that I find really, really helpful with hyperlink is this very specific string, which allows you to jump to cell A1 of the sheet name specified in A2. That allows you to change the value or the text string in A2 and drive people to different locations in your worksheet dynamically, which is very cool. The only catch is it's a lot of single and double quotation marks that are very easy to screw up. So let's jump into Excel and see if we can get this thing right. I'm on the Pick a Door tab, which is currently just a blank worksheet. And what I want to do here is basically just create a link that will drive the user to either door 1, door 2, or door 3. So if I just type door 1 here, what I can do now in cell B5 is write a hyperlink function that creates a link that when the user clicks that link, they'll jump to the door 1 sheet because that's the name indicated in cell B3. So let's test that out and do equals hyperlink. And now this is where we need to pay incredibly close attention to the keystrokes here, because if you miss one little thing, it's not going to work. So let's get nice and zoomed in. And what we're going to do is we're going to hyperlink to open quote, hashtag, single quote, double quote, the ampersand. So we're going to start with the hashtag single quote, and then we're going to merge that text with whatever text is in B3. Then another ampersand, open the quotes again, add another single quote. Then we're going to do exclamation point, A1. And you'll see that this is kind of following the way that Excel names sheets within workbooks. You've probably seen that sometimes you do a reference across sheets and it automatically adds these hash marks and these exclamation points. Basically, we're replicating that with manual text strings. So close the string there. And then that's my link location. I know it looks like a total mess of gibberish, but trust me, it makes sense. And then the friendly name is just whatever text string you want this button to show. I'll put it in quotes. So I'm going to call it pick a door. And then close off the parentheses, hit enter. So now it's inserted a link. You can see it's formatted as a link that just says pick a door. So if I click this, it's going to go to cell A1 of door 1. So when I do that, there we go. We're on the door 1 tab, which is a ridiculous cat face of Nicolas Cage. So let's jump back and add a little bit of a dynamic element to this just to make it a little bit more fun. What I'm going to do, follow along here. So I'm going to create a little array of data with a 1, a 2, and a 3. Next to the 1, I'm going to type door 1. Next to the 2, I'm going to type door 2. 3, I'm going to type door 3. Now what I want to do is in cell A3, insert a random number generator, rand between 1 and 3, so that every time this worksheet calculates, remember I can go into formula, press calculate now, that random number generator will generate either a 1 or a 2 or a 3. Now what I want to do, instead of just typing door 1 as a concrete value here, let's just change it to a lookup that's tied to a random number generator. So we're going to look up whatever the generators spit out within this array we just created and grab the name in the second column. So now when I calculate, see that not only does the number change, but the reference changes too. And then last but not least, I'm going to just do a little shortcut and white out this text so that we don't know what's coming. I'm going to press the calculate now button a few times, get it nice and random, and then pick a door. Yep, so there we go. We're on door 3 now, which is another hilarious Nick Cage-faced kitten. Back to pick a door, and we can try that again. A couple more times. Door 1. Couple more times. Door 1 again. So you get the idea. It's obviously this might not be the most academic or relevant application of using hyperlink, but I've been recording these sessions for many weeks now, and I wanted to have a little bit of fun. So there you go. Hyperlink function, really useful.
All right, so we've arrived at our final lecture of the course. Please try to hold back tears, because you're in luck. I've saved possibly my favorite function for last, web service along with filter XML. One thing to note, web service didn't become available until Excel 2013, so if you are using an older program, I apologize, you may run into issues with usability, and maybe that will inspire you to upgrade to the 2013 version of Excel. So the example that I'm going to show you is specifically using the Weather Underground API to pull in real-time weather information. And there's a little bit of setup that needs to take place. So rather than building it from scratch step by step, I've built this little tool out here. I'm going to show you how it's built, how each of the components work together, so that you can then go and customize it and build something similar on your own. So for this particular example, we need 2 pieces of information, a zip code and an API key. And regardless of the API that you're tapping into, you're going to need some sort of API key so you can get that through the API developer website. In this case, since I'm working with Weather Underground, if you just go to wonderground.com/weather/API, there are links to get your free API key here. I think you just have to insert an email address and they'll send you your own key. So that's how you can get that. Now, this is my personal key. If it's not working, let me know and we can refresh it. Or you can go to the address I just showed you and create your own key. So those are the two pieces I need. And then the web service function itself, all it does is input the URL and spit out a whole bunch of XML data. So as you can see, I've got a whole text string with the beginning of the URL. And then I'm integrating the value from cell C3, which is my zip code, as well as cell C2, which is my API key. And then it ends with .xml, so that when you hit enter, it spits out all of this information pertinent to this specific zip code. So this is a really messy, really unfiltered, disorganized dump of XML data. So it's giving me interesting stuff. It's just not very usable. And that's where filter XML comes in. So filter XML is what allows you to parse through that XML output and extract individual bits of data like current temperature, feels like temperature, precipitation conditions, etc. So the current temp formula is just filter XML E3, which is that long XML string. And then the second piece is just the XPath. And now this differs depending on the API that you're working with. In this particular case, to pull in the temperature, I use temp_F to get the temperature in Fahrenheit. Similarly, for the feels like temp, I would use feels_F. So each of these variables that I'm extracting has its own XPath value. So wind_mph is wind speed in miles per hour. And to know exactly what those XPaths are, you again have to go to the documentation from the API developer. So back to the web. Remember, we got our API key from wonderground.com. There's another link on that page called documentation. And this box called response fields basically outlines all of the options that I can return. So there's the feels like temp that I was using. And you can see there are dozens and dozens of these options. So that's how I know exactly what the XPath needs to take. And sometimes, to be honest, it just takes a little bit of guessing and checking to make sure we're getting them right. So as you can see, I've got a number of different variables that I'm pulling out of this string. Visibility, air pressure. I also have information about the location. So I've got Boston, Mass, which is tied to the zip code 02215. This is the station ID, latitude, longitude. And then observation time tells me exactly when this data was last updated. So now all I need to do, if I want to check the weather conditions for a different zip code, is just type it in right here. So if I do Beverly Hills 90210, now it's telling me it's 74.5, little overcast, wind coming in from the south, pretty good visibility, 9 miles. And here's the location information, and it was last updated on August 21st at 12:25 p.m. So you can type in anything you want here, and it will go ahead and update all of this information in real time on demand. So that's the Weather Underground API. Really just one very specific example. Once you get the concept down, you can apply this to a number of different data sources as long as an API is available. I'm going to jump over to a tool that I actually built about a year ago, 6 months ago, which pulls in accident data from the city of Cambridge, Massachusetts. And just want to show you one feature of this tool. Essentially what it's doing is it's mapping out accident locations based on mode of transportation. So auto accidents, cycling accidents, pedestrian accidents. You can see I've got a weather feed coming in, which is tapping into that same API I just showed you. But one additional feature here is that you can type in a start location and a destination. I'm just going to type 1 Spring Street, Cambridge, Mass. And then when you hit this check route button, what it does is actually tap into the Google Directions API and uses filter XML to pull out the step-by-step text directions. And then it bounces those directions off of our raw accident data to identify if this user is passing through some of the routes that we've identified as particularly dangerous based on accident rates. So in this case, if I were going from Commonwealth Ave to Spring Street in Cambridge, it tells me, heads up, the accident risk for this route is moderate. Be careful on Cambridge Street, especially the intersection of Cambridge and Windsor. So that's an example of how to use the Google Directions API. This one took a bit more time to set up, including some VBA code, but just want to showcase that the opportunities to use this type of function are virtually endless. So with that, we've wrapped up our bonus badass functions. If you have any questions about any of these, web service, filter XML, offset, any of the earlier lectures or sections, please make a comment or reach out directly, and I'd be happy to help you out. Thanks so much.